Good day everyone, Mr. Cargill here with our next AutoCAD video. Now in this video we're going to be looking at the 2019 Technical Drawing Paper 1 past paper. So let's get straight into it. Question 1. In the figure above, A, B, C, D, E, F is a regular hexagon. What is the value of X? X is right here. X will be 60 degrees. This is a straight line. Angles on a straight line is 180. This is 120, which means that X is 60. Question 2. The diagram illustrates the proper method of what we're doing here is finding the foci points, or the focal points, the normal and the tangent of the ellipse. So these are the different foci points here, and then here we have the normal and the tangent. Question number 3. The diagram above shows the construction of a triangle when given the hypotenuse and one angle. So one side and an angle is what you would need to construct this triangle here. In the diagram above, ABCD is a parallelogram. The triangle CDE is equal in area too. So this triangle is equal in area to half of the parallelogram. So if a triangle and a parallelogram share the same base and height, then the triangle is going to be half the size, half the area, of that parallelogram, or just a quadrilateral generally. Alright, number 5 here says, in the construction above, the angle X is 75 degrees. So this is angle X right here. This is 90 degrees and this is 3/4 of that, which would mean that this is 75, and we can see that we bisect here to get a 60-degree angle. Then we split this part in two here. So this is 60, which means that this is 30. Split that 30 in two. So this is 60 plus 15, which is 75 degrees. Number 6, the fire emergency exit door leading from a workshop should open outwards. You don't want it to open inwards to obstruct anything, and it's just easier to push than to pull generally. Item 7. The conic section AA appears as a parabola. So if you cut the cone like that, when you're looking at it from that angle, what you're going to be seeing is going to look like a parabola. Number 8. When a straight line touches an arc and forms a right angle with the radius of the circle, then a point of tangency is formed. Item 9 refers to the following diagram. In the diagram, EF to EF1, which is right here, is in the ratio of 3/4. The length of EF1 is, what's the length of this line from E to F1? That will be 60. Or we know it's 60 because this is 3/4 of this total length, and 45 is 3/4 of 60. So if we add the next 15 now, we get 60 here. Number 10 refers to the following diagram of a square in area to a rectangle. Alright, so the square is equal in area to the rectangle. This is the construction here. What is the length of EF in the construction? So in this case, EF here is going to be equal to 55. Alright, number 11 refers to the following construction. Which of the following construction is illustrated above? This is circles in isometric. So this is how you go about drawing your lines to draw circles in isometric construction if you were doing it on paper. Number 12. In the diagram, which of the labeled types of lines indicates a cutting plane line? That would be 2. That shows that cutting plane line. Look right across there. Number 13 refers to the following diagram, which shows the orthographic projection of a block. On which of the following planes is the plan shown? And it says it's shown on 3 only. So this is where the plan is. Alright, this is the only place you'll see the plan. Right here it's in the front, right here it's in the side. So it's just on this plane. So 3 only. Item 14. Which of the following can be found if the major and minor axes are given? Can we find radial lines? Can we find parallel lines? Can we find intersecting lines? Can we find focal points? And here we can find focal points. Alright, and this is number 15 now. Number 15. Which of the following polygons can be constructed in the circle that has a radius of 8p? Alright, so 8p, the radius 8p means that from here to here. What can we construct? We can construct an octagon. And we know that because it's 8. And this has an octagon has 8 sides. If we did it here, we could construct a square. 6 would be a hexagon, 5 a pentagon, so on and so forth. Number 16, if the perimeter of a triangle is 120 millimeters and its sides are in the portion 4, 5, 3 respectively, then the length of the sides in millimeter would be 40, 50, and 30, because 40 plus 50 is 90 plus 30 gives you 120. All right, number 17. Which of the following is used to draw an octagon if the length of one side is given? So if you get the length of one side of an octagon, what could you use to draw it? It says a 45-degree set square. All right, now we are at number 18. It says item 18 refers to the following diagram, which is this diagram right here. In the drawing above, in order to divide AB in the ratio 4:5:3 by proportional divisions, it is necessary to first step off 12 equal divisions. So that's what we'll need to do. Step off 12 equal divisions and then separate that into 4, 5, and 3. Item 19. Given that one of the angles of a rhombus is 120 degrees, which of the following is the value of one of the interior adjacent angles? And that would be 60 degrees. Item 20 refers to the following diagram. What is the value of angle P in the diagram? And angle P has to be 30 degrees. How do we know? Angles on a straight line add up to 180 degrees. 90 plus 60 is 150, so we need an next 30 to make 180, so it is 30 degrees. 21. A quadrilateral with one pair of parallel sides is a trapezium. 22. Which of the following diagrams shows triangles of equal area between parallel lines? This one. So we know that these are of equal area because triangles with the same base and the same height will be equal in area. So they have the same base and they have the same height, so they are equal in area. Item 23 refers to the following diagram, which are using orthographic projection for the diagram above, with view G as the front, so G is the front. The end view H will be, what will H look like? Yeah, H would look like this right here. So you see these lines at the edge right here. You might say, well, how are we seeing these lines here? But when you look at H here, I don't see any line here. This is open and this is open. Well, if you look all the way back, you will see that you will see this line here, which would be here. And with that, we have to assume it's symmetrical. And so we're going to be seeing that over here as well. So the answer would indeed be A. We know it's not this because this wouldn't be any broken lines. We're actually seeing that. So the answer is A. 24. Which of the following diagrams best represents an external and an internal tangent? So that would be this one right here. We have an external tangent right here and we have an internal tangent right here. This is two externals, this is two internals, this is also two internals. Number 25. Which of the following diagrams shows the proper method of bisecting an angle? And this is the construction right here, where we go about bisecting an angle. So we draw an arc, and then we get this point, open our compass to any convenient radius, scribe an arc, come over here with the same radius, scribe an arc, and then we bisect that angle. 26. If a car picks up a tack on the circumference of one of its tires, then the path traced by the tack as the car is driven is called a cycloid. Item 27 refers to the diagram below. In the diagram, the ratio of the area of EFGH to that of EGIJ is, it says that it is 1 to 2, which means that it is half the size. So let me see, EFGH, so this is EFGH, and then the next one is EGIJ, so this is EGIJ, so it is half the size of the square here. All right, number 28. Which of the following diagrams correctly shows the bisector of line AB? So this is the bisector of line AB. This is line AB. This is also just line AB. This isn't the bisector. These are the arcs. This is the actual line that bisects it. So the answer is indeed B here. Item 29 refers to the following instrument. Which of the following represents the size angle X in the drawing instrument shown? X over here, that is the 30-degree angle. All right. So let's move on to number 30. Which of the following diagrams represents the drawing of a tangent to a circle at a point on the circumference. So which of the following diagrams represent the drawing of a tangent to a circle at a point if we extend on the circumference? Here, so a tangent that to a circle, okay, at a point on the circumference. So let me see here. Then what we're going to end up with now, we're going to end up with that arc. We bisect that and then we get the tangent. So the answer is A. It's not B or C, nor would it be D. So the answer is A. So item 31. If the length of a line on a drawing is 25 millimeters and the scale is 1 to 10, then the actual length would be 250 millimeters. So 250 millimeters would be the actual length. Item 23 refers to the following rectilinear figure. The rectilinear accuracy of the figure can be tested by measuring its diagonals. So you can find that out if you measure the diagonals. Item 33 refers to the following diagram. Which of the following is the eccentricity of FPPQ in the diagram above? And it's 1 to 1 because QP and PF are the same lengths. So the ratio of eccentricity is 1 to 1, which means that that is a parabola. All right, let's move to item 34 now. Which of the following developments shows a cylinder with it which is cut obliquely at both ends? The answer would be D. So that's cut at both ends. A is cut only at the top, B isn't cut at all, C isn't cut at all. So the answer is indeed D. Item 35. Which of the following instruments is used when drawing an irregular curve on a surface development? And what you would use would be a French curve. Item 36. The diagram shows the development of a truncated cylindrical pipe. And you can see if you fold that, then you would end up getting a cylindrical pipe and the top of the pipe would be cut off, which means it's truncated. Item 37. The perpendicular distance between the lines PQ and RS of a trapezium PQRS is 3.5 centimeter. Which of the following lines would be parallel? PR and QS would be parallel. Item 38 refers to the following diagram. The lines marked X on the diagram are symbols which indicate the continuation of the objects. So those points there shows that the figures continue. Those symbols show that they continue. Item 39. Triangle ABC is drawn within a semicircle. Of diameter 100 millimeters. AB is equal to 80. What is the length of BC? And that would be 60. It's because it's a right angle triangle, so it's a 3, 4, 5 triangle. So 100 being 5, 80 being 4. So the next one would be 3. All right, so we move on now to the next question over here. Item 41 here. It says item 41 refers to the following diagram, which shows the intersection of 3 isometric axes. What is the angle of that right there? And that would be 60. So even though orthographic is drawn at a 30-degree angle, if you draw a 180 line, like a horizontal line, then one part would be 30, and then that next angle that's represented there would actually be 60 degrees. Item 42. Which of the following shapes is a pentagon? That is C. Should be getting that one wrong. Item 43. When a craftsman is drawing a true horizontal line, a pencil point should be guided by a T-square. So you should be using a T-square to help drawing your horizontal lines. 44. Which of the following best describes the quadrilateral? That would be a plane figure bounded by 4 straight lines and the interior angles add up to 360 degrees. Item 45. Which of the following diagrams shows the correct division of a line? And that would be C. So it shows how we are dividing that into a ratio of 2 to 3. Alright, so yeah. So let's move on now. Item 46, which are the following methods of drawing an ellipse involves construction of a rectangle? That would be the intersecting lines method, which is also called the rectangle method, but they wouldn't put the rectangle method there because that would be too simple. Item 47. A development of an object is a drawing showing the unfolding of the surfaces, so a surface development drawing. Which of the following diagrams shows the correct procedure for drawing a perpendicular at the end of a line? And that would be B, where you describe an arc, then with the same radius, you bisect that arc twice, and then you put your compass point as the first bisecting point, draw an arc, put at the next one, describe an arc again, and then you connect that point where the two arcs meet to the end of the line. And that's how you draw the perpendicular at the end of the line. Item 49. In technical drawing, the phrase curves meeting each other tangentially means that the curves will meet smoothly. Lovely. So now we move on to number 50. In the diagram, a crank QR rotates about a fixed center R. A rod PQ is pinpointed to the crank at Q and freely slides in guides at P. The locus traced by point S for one revolution would be a cone. So when it's moving around, if you should plot that point for one revolution, you get would be in the shape of a cone. 51. The drawing above is to be reproduced in third angle orthographic projection. On which of the following views can the distance x be measured? That would be on the plan view and also the side or the end. So that would be 1 and 2 only. You wouldn't see it on the front, but you would see it on the plan view and the end view. Item 52 here says, a netball court has a length of 30 meters. A line representing this distance measures 3 centimeters. To what scale is the line drawn? And that would be 1 to 1000 because it's 30 meters. If it was 3 meters, it would be 100. But it's 30 meters, so it's 1000. Item 53. Which of the following is a view of a right square pyramid? That would be C. D is a hexagonal base, B is not a pyramid, and A is a cone. So the answer is C. Yeah. So item 54. Which of the following views could show an object as if it were cut across, exposing the inside details? And that would be a sectional. 55. When designing a new product, which type of drawing do you do first? That would be the sketches. 56. Which of the following layouts represent the correct orthographic projection of a shape block? And that would be B right there. So the plan view is always by itself. Then in this case, you have the front above the plan, and then you have the end view beside the front view. So we move on now to item 57. A circle is drawn inside a polygon. If that circle touches all the sides of the polygon, it is known as an inscribed circle because it's on the inside. 58. A student falls and hits his head hard against the edge of a technical drawing table is most likely to suffer a concussion. Be safe in the workshop. Item 59. The diagram shows the construction of a regular hexagon given the length and the sides. All right. So a regular hexagon given the length and the sides is what that figure shows. We move on now to the last question. Item 60 says, item 60 refers to the following diagram. Which of the following representations is correct for the first angle orthographic projection of the object shown? That would be C. It's in first angle, so we'd have the plan down there by itself, the front above it, and then would have the left on the right side of the front. So the answer here would be C. Good. So thank you for watching. Please remember to like, subscribe, and share. Let other people know what's happening. I do hope you found this video helpful as a 2019 Technical Drawing Paper 1. So thank you for watching and have yourselves a fantastic day.